We honored to have Mr. Akirul Rahman, Chief Technology Officer at Hitachi Energy India Limited. In Hitachi Energy, Akirul Rahman is a leading technology, digitalization, and innovation towards the market and customers in India and supporting market innovation in South Asia. He has more than 3 decades of experience in research, R&D, technology, and management engineering consulting businesses, in product development in power, automation and digitalization, and digital technologies. With a master's degree in electric engineering from Kharagpur, Akirul has held various international and global roles in India, Germany, and Switzerland, including head of global collaborative production management, engineering, and cybersecurity in process industrial automation. Today, Mr. Rahman will talk about technology and digitalization for a smart and intelligent energy grid.
When it comes to smart electricity, intelligent electricity, I think it's very important also to consider the grid. And grid, which is basically delivering the electricity, which is smart, but also starting from the source of energy, the electric energy, and also how it is transmitted, how it is distributed, how it is stored in the present context. That's important. And then how the grid is going to be transforming in future with the core technologies of the power systems and also the digitalization. So that is what I am going to briefly touch upon here. So the future of energy system, if you see, today we are talking about sustainability, the carbon neutral future, and we know that as a country we have announced 2070 is going to be carbon neutral year for us, but we also have the interim target. Now we are heavily moving towards renewable energy storage. By 2030 we plan to have 500 gigawatts of renewable energy in the country. Half of the electric energy is going to come from the renewable. So looking at this space, it's a energy transformation happening in line with the sustainability goals, and the technologies which are going to be there, which are getting implemented, whether in the generation side, wind energy, of course it has been there, but it is more and more getting popular. But more so primarily in India, it is solar energy, and of course hydropower, the conventional energy we already have. On the transmission and distribution side, how do we deliver this power energy from remote sources, including offshore? How do we deliver that, reliably? Is where the power electronics is going to be used with HVDC, FACTS technology, and substation. They are going to be very important. Distribution substation, receiving substation. On the other hand, also, how do we use this green energy, renewable energy, for, let's say, the hydrogen, generation, green hydrogen, which that as using the the renewable energy when we produce hydrogen using electrolyzer process. So that becomes the green hydrogen, and that can be used in the process industry. It can be used for fuel cell. And of course, the consumption side, there are huge demand on the data center. It needs reliable power. Also, the reliable, the green power, at the same time having a lot of power electronics to control this type of power. Transportation, we know that the electric vehicle charging in different forms in terms of speed. If you see the normal speed, the fast charging, 15-20 minutes charging, you charge for 200-300 kilometers, but also ultra fast charging, few minutes, 5 minutes you charge for 200 kilometers. But flash charging is the technology where it is electric buses which can be charged when they're stopping near the bus stop. That's a flash charging, 20-second charging, top up charging there. And this is not just the individual vehicle, but also the fleet, the integrated charging infrastructure, where a lot of different type of vehicles and different modes of charging, electric vehicle charging is available, whether it's plug-in or it is swapping, battery swapping. And the energy, as we know, it is impacting all the sectors: utility, renewables, transportation, data center, industry, buildings, and more in the process and building side. The electrification is going to happen, and which is going to demand very smart, reliable, but green energy, the electricity from the grid, and grid has to deliver that. And if we look at the picture here, so this is a picture of the power system of future, where on top of the AC, conventional AC grid, we are going to have more and more DC in terms of HVDC, medium voltage DC. And right from generation, if you see how the entire generation portfolio is going to change, the mix of generation is changing. As I said, more of the renewable energy, whether it's wind, also pumped hydroelectric, and of course the solar. So how do we transmit this energy, bulk of energy from remote areas? For example, in India, as we know that in Leh, Ladakh area, in Himalaya, there are 20 gigawatts of renewable energy is being planned, the solar energy and also some top up of the wind energy. And then how that energy can be delivered to the center of the country so that the grid can take it and distribute. So there, the HVDC plays a major role. HVDC not just point to point, but as we go, the system is going to be more and more complex in terms of multiple HVDC lines getting connected. So it will lead to multi-terminal HVDC, then meshed HVDC. And then the other hand, the renewable energy which will be used for hydrogen, green hydrogen, making the green hydrogen where it can be used for the process industry instead of chemical process, so where the carbon footprint can be reduced. But the same green hydrogen also can be used for fuel cell based electric vehicles, can be also used for fuel cell based storage of energy. And then we will also have a lot of microgrids, the microgrid technology, which can be used for including the local renewable generation, but storage, operating off grid, but also connected to the grid whenever it is required. And on the right hand side, you see a lot of different type of loads, as I talked about, whether it is the electric mobility, EV charging, but also railway electrification, as we know. But a lot of industry loads, which are non-electrical, loads, they are going to be also converted to electric type of load, and then that is going to put a lot of demand on the grid, and the grid has to be controlled in real time and be reliable. So that can be achieved because with more and more renewable energy, we are losing also momentum in the system, the spinning reserve in the system not having enough of the rotating machine and generation. So that way, power electronics is going to play a major role in controlling this power flow, bidirectional power flow, controlling the power zero to maximum, and that has to be done in the real time. And HVDC technique, the DC technology, can achieve that. So HVDC not going to be just used for the long distance transmission, but also the shorter distance, but also controlling the grid, providing the inertia in the system, the virtual inertia in the system. So then coming to our conventional grid, we know that we have the primary equipment in the grid, the transformer, the switch gear, the substation automation products, the devices, the connectors, but also we have the SCADA, we have the EMS. So this automation system has been there in power grid since many decades. It's not new to us. I think it's there much before even the IT industry started talking about automation or digitalization. So this system is very reliable, having the network control, network management, and also the very critical communication which basically takes care of the deterministic nature of the power network and the control. So, but what we have been also started doing is using different digital technologies, whether you talk about virtual reality, augmented reality, digital twin, digital simulation in power system. Power grid has been there for several 30-40 years. It has been there since the inception of computers. We have been using it, and also the artificial intelligence, machine learning, and big data analytics. A lot of connectivity protocols we have. Blockchain also we are using for smart contracts for the renewable energy, the power purchase agreement, and cloud computing, of course, being used. So I'll show you some examples. Talk about some examples. But very important is also the cybersecurity, because we have more and more connectivity. So how we are going to have the conventional core technology of the electricity generation, transmission, distribution, but on top of that, the core automation, which we have been doing, but digitalization. So it's all about how we connect additional sensors, collect the data, additional data from the core system, the OT and automation system, and have the data available in the cloud so that this data can be available to the largest set of experts, largest set of service providers. Combine this data with different, type of data like weather, market, user requirements, and use digital technologies basically to ensure that we have some KPIs, smart KPIs, the key performance indicators in terms of productivity, reliability, quality, asset health, energy efficiency, safety, environment, security. These are the KPIs which can be achieved by using this digital technologies. So what it means is that we have the core, the automation system there. We extend that with the IoT digitalization, with the sensor, with the edge. Then we achieve these additional KPIs for basically improving the asset and operation performance. Having all these technologies, and what is required to make it more smarter, of course, is a partnership among different stakeholders, different OEMs, technology providers, but also the customers, the utilities, the industries, and of course, involving the academia to move into this space of new way of converging these technologies, the core technology of power automation with the digital technologies to achieve these KPIs in real time. And of course, there will be also business models, whether we talk about energy as a storage, battery as a storage, charging as a battery as a service, and charging as a service, and energy as a service. So these are the new business model also evolving along with the technology. I think this needs larger collaboration among different stakeholders to achieve this, achieve a smarter and also intelligent grid, which will provide smart electricity to the consumers, to the prosumers, who are going to be both consuming as well as sometimes producing electricity.
Thank you, Mr. Rahman, for sharing your views on technology and digitalization for a smart, intelligent energy grid.